we're going to be talking about insulation and insulating properties of different materials. And our group of participants here is going to be helping us by testing how to keep the cold out, and particularly out of a film canister of water. We have a variety of materials set out here for them: cotton balls, feathers, aluminum foil, foam, construction paper. And we're going to see if they can layer the outside of this film canister so as to keep it from freezing for the longest period of time in a typical freezer. Now, this requires youngsters in the classroom to understand the idea of a control, that one film canister will have nothing applied to the outside. It will remain just as it is, filled with the same amount of water as the film canisters that they cover. We will keep them in the freezer, and after a period of time, take them out, measure the temperatures, and see if indeed they have kept the cold out. One of the other activities in the packet requires kids to keep the heat in, and you'll want to look at that activity as a companion to this one, keeping heat in, keeping cold out. So, your challenge, participants, is to work on this. You may layer as many layers as you would like. Don't cover the top or keep the top from being securely fastened, or your water won't stay inside the canister. Any questions? Have fun.
I think that is because, you know, so many coats are made out of down that this must be a good insulator. Okay. I'm going to try mine on for that. Yeah, cotton is good.
Old silk, like in the old days, and stuff with cotton.
Do you want some cotton? Let's give you some here. This is something good that you can use in your classroom. It doesn't, not very messy.
And nothing's very expensive.
That's always a consideration. Should we leave the bottom protected, or does it have to stay plain?
I would say go ahead and protect it just as long as it is able to set up.
Chuck, I heard you refer to two activities, one on keeping cold out and the other keeping heat in. Would you please distinguish between the two?
Sure. On this particular activity, the heat that we're thinking about is in the airspace and in the water that's inside the canister. And to kids, the idea of the ambient cold trying to get in and freeze the water that is in there. But in reality, the heat is in there, and that is the same as really the first activity, in which they put a light bulb inside of a Xerox box that they have insulated, and they're trying to keep the temperature inside the box as constant as possible after they turn the light out, and keep that heat from being radiated outside of the box. So in reality, scientifically, these are both one and the same. For the child's mind, this one is different in that you're placing it in a cold environment and seeing if you can keep that trapped heat inside. With the early childhood classroom, this is a wonderful activity. It doesn't require a whole lot of skill. They're small.
As you can see.
These are small canisters. It takes the kids only a while to be able to insulate them. And whereas the preschooler may not have a directed purpose in what they place on there, you can take preschool thermometers, which only gauge warm and colder, and show them that the results when they come out of the freezer. So even younger children can learn this and start talking about clothing and the importance of hats and layers of clothes. This is beautiful. So, looks like a neat hat here on there. We will fill these all with the same amount of water. Again, that is the fair test feature. Nothing can be done to one that isn't done to them all, so they have to have the same amount of water. And the control here in terms of layers and material, there's a point at which you're really not going to be able to successfully get materials around this. Some of the constraints that you can use is 5 layers of materials, or 3 layers, or 1 inch of materials. So the constraints that you give the student, you can give them the constraint of color. All the materials you must use are red, or all the materials you use are green, and see what differentiation color has to do with this. Are we ready to fill these with water? And we need one for control. We put the same amount of water in each. We're now ready to put them in the freezer. Connie, would you open the freezer for me? And Shireen, let's put yours in. Thank you. Okay, thank you, Glenn.
Yeah.
It's been 2 hours now. Let's measure the temperature of our canisters. We're back from the freezer, and we're going to see the results of the canisters having been in the freezer now for a while and see what the temperatures are. Let's start with the control.
Control temperature is 0 degrees.
Okay, so we have freezing on that one. Okay, let's see what the temperatures are in the other. Start over here.
Mine is right at 9 degrees Celsius.
Mine's at 12 degrees Celsius.
That means that yours is closer to room temperature than mine is.
Right, which means that my hypothesis about the feathers being a good insulator was correct.
Right, I should have listened.
Those birds know something, don't they?
Mine shows 9 degrees Celsius.
Okay. And you will see a variety of ranges. We didn't do that. We didn't do this in this activity. You could take them out periodically and graph the results, which is a good exercise in math for them. Just make sure that they're all out for the same period of time. They all go back in. And you probably don't want to do that any more frequently than about 15, 20 minutes apart.
Connie mentioned something that's good to do with the kids. This particular thermometer that we have has both degrees Fahrenheit and degrees Celsius, and that is to draw attention to those two different scales. Whether or not you teach them to convert, they need to be able to read both of them and to associate certain degrees with cold or with hot or with room temperature.
Certainly, you want them to know in each the freezing point, boiling point, room temperature. Do you have other questions, Wendy?
I just wanted to make a comment about the film canisters, that you go to any developing store and they're more than willing to give you bags full of them.
Yes, that's true.
Also, I was wondering, would it make a difference, and it would be a good investigation, to use clear canisters, not just the opaque ones, but to try some clear canisters and see how that would come out?
Good idea. And again, I think we had some discussion up here of how many variables can be changed. If you have access to someone who has the old film canisters, and I think maybe even some companies may still make them, which are metal, or could even find something similar of this size that is metal, does that make a difference in the transfer of heat from within to without?